you have. So with that in mind, I don't care how much time we take for this, but I don't lead reviews. But after me clarifying what was on it the other day, suggesting some problems. What do you want? 31. Which one? 31. Oh, so 226, number 31? Okay. 226, number 31. Okay, automotive engineering. I just thought this one had cars, so we got to do it. I love my cars. The fuel efficiency in miles per gallon, certain mid-sized car at various speeds in miles per hour is given by the table below. Right now, these auto manufacturers are doing anything they possibly can to get better fuel mileage. It is nuts what they're doing. Like on my truck, there are all what's called the swing panels are aluminum. The doors are aluminum, the hood's aluminum, the tailgate's aluminum. To make it lighter. That's the only reason. I wish they would make the bedsides aluminum because then they wouldn't rust like Chevys typically do. But anyway, that's a whole other story. But one of the things they're doing, and you've probably heard some of the ramifications of this, is they are taking what's called active fuel management and variable displacement. So they will shut down certain cylinders in your engine when they're not needed. So you might have a V8 that going down the highway at very light loads, you might be running in a V4 configuration. So they've got these valves that are adjustable, and it's biting them in the butt because just the couple that I know of that I've just researched lately, because I have a friend that has this one, the Chrysler 3.6 has had a lot of failure in the valve train because they're trying to manipulate the valve train to shut it down certain times to get better mileage. Chevrolet has had all of their 6.2 engines recalled, and it's going to cost them a little bit over $1 billion to do this. It's like 900,000 engines they've recalled. Well, I don't know. And like say one guy that I know, an older guy, he had a 6.2, was driving down the road, boom, it quit.
The engine just quit?
Engine just quit. And they've got some of these engines that are failing after like 4 miles. And so there's some big problems with them because they're trying to make even the reciprocating assemblies lighter, cheaper, but a lot of it's having to do with this trying to do whatever they can to get better mileage out of these vehicles. So it's a big deal because the government has these what's called CAFE standards that by certain years your average fuel mileage of all your vehicles you sell has to be under a certain point. Okay, so it's interesting. So anyway, so on this one, I'm just going to go ahead and cram this information in real quick. If you, at any point in time, need to know where I'm getting this information from, please don't hesitate to ask me. You should have already gone through this, but I'll just crank through this real quick. Stat, edit, clear, don't delete, clear. So I'm just going to type in every 5 miles. 25, 30, 35. And that's actually why a lot of these vehicles anymore have transmissions with so many speeds. Because there's a certain RPM range that your engine's most efficient. If you have a 10-speed transmission, you can keep that engine in that more efficient range for a longer period of time. And that's another thing that they're having problems with is like GM, their 10-speed transmission is failing on a fairly regular basis.
Any automatic or manual transmissions are better for a car?
I don't know. I own both. For mileage, manuals have typically been better. but then the automatics are getting better with all that stuff. So times change. Like right now, you can't buy. I think this is the case. I don't think you can buy a Corvette that's a stick shift anymore.
Really? Is it just paddles or?
Yes.
That sounds right.
Okay. So we got that. So I'm just going to go ahead and I'm going to go zoom stat. It picks my window for me. That's all it does. It just picks my window for me. And hold on, that doesn't work very well. Okay. I'm demonstrating a bouncing ball in Algebra 2, so.
Pretty cool.
I've never seen that.
Oh, really? It's kind of a fun little equation to try and write. Clear, plot on, zoom stat. Let's try this again. Okay. So there's my efficiency graph. Really tails off. Really tails off. So this might be in a vehicle that, when it's doing 70, 75, the engine's going like 3,000 RPM, 3,500 RPM, and really sucking down some fuel. Okay. Back in the day, believe it or not, the early 60s cars had like 2-speed automatic transmissions. That was it, 2 speeds. So if when you were going 60, 70 miles an hour, your engine was spinning. But now, like in my Corvette, if I go 70, it's probably going 1,600 RPM. It's just spinning really low. Okay, so you get this? Julie, you got it? Okay. Okay, so now I'm just going to go, I want to do a calculation, but I don't use this calculation up top. I got to use a stat calc. I'm going to come down to quadratic, and that'll give me my quadratic equation. It's going to open down, obviously, so my leading coefficient is negative. This one, my r squared value, it just shows my r squared, but not my r. Oh, okay. My r squared value is 0.98, so it fits pretty well. Now if I go to y equals, and I can go vars, stat, equation, graph, and it actually fits really nicely. Okay. Now, so the thing that I think is really cool is when you start getting into this equation, it says, use the model to predict your fuel efficiency of this car when it's traveling at a speed of 50. Well, make a table and look at it when it's 50. So, table. I can even go by every 10 miles an hour if I want. It doesn't really matter. Then I build my table. And at 50, there you go. 33 miles an hour. Okay? And again, I don't know what, the level of experience you've had with graphing calculators and stuff. So, your guidance to me would be, asking questions so I can slow down, speed up, or whatever the case may be. But I think this is where it gets more interesting to make predictions. No doubt about it. If you're not good at the table, you could just go back to this, write it down. Negative 0.0615x squared plus 1.367x plus 5.625 or 685, and then plug in 50. Okay. And it is amazing how many things in the world are related by quadratic equations. One of the things I really like that's kind of cool is skid marks on a car. The length of those skid marks is a quadratic relationship to the speed of the car. So if you measure skid marks and then you just do some testing on the coefficient of kinetic friction on the surface, you can find out how fast they were going really easily. There are state patrol people who their specialty is to be accident reconstructionists. So if there's an accident, and they want to know, okay, how fast was this car going when this happened, so we can figure out some charges. Should it be vehicular manslaughter or just a regular accident or whatever? Then that person comes in, takes all the measurements, and goes, does all the math, and then decides, okay, this is how fast I think they were going when they hit that telephone pole. So I think it's very interesting. That'd be an interesting gig. Because by that time, all the gory stuff's cleaned up. I did have one student. I don't know if I've told you this before. I've had probably 10 to 15 past students die in traffic accidents. And one of them was in a short car, driving by Logan View, reached over to the side, they think, to pick up a cassette tape or something like that, or something to listen to some music, and he went underneath that cable guardrail in his little Honda Prelude. Took the whole top of the car off. So I could tell you story after story about kids that I've taught passing away, and it's not good. So have you guys had issues like that here at all?
In the past couple years, like 2.
Really? A couple, really?
Here, but like,
Yeah.
the girl, a girl in PA died, and then.
Oh, that's right. It was on her own place, wasn't it?
Yeah.
Yeah, where a farm worker came around. I heard about that. That was terrible.
Yeah.
That was terrible.
And then the Wisner,
Yeah.
the Wisner athlete.
So it's just one of those things that. Oh, at practice, that guy.
Hear about that?
Yeah. Yep.
Did they ever find out like the reason for that?
I have no idea. So anyway, just my little.
Oh, we did have a guy who died like 3 years ago here.
Really? Was he a student?
Yeah.
Where he just graduated.
What, a traffic deal or what?
He was driving under the influence.
I'll tell you what, you really got to take care when you're driving. There's no doubt about it. I mean, it's one of our kids. He and his girlfriend were coming from Oakland, coming over to West Point, and they had forgot something, so he pulled over and was going to do a U-turn, and did it right in front of a semi. And I loved that kid. God, I love that kid. He was a great kid. He struggled in my classes, but he'd come in every day, and he'd be like, "Hey, how you doing?" And we'd work on it, and he'd go, "Oh, okay, I get it now." But God, he was a hard worker and great kid. So anyway, okay, Julie, did that help? Yeah. Okay, what?
We 35.
35 from the same section. Okay. This one, data and table to the right, was collected on 5 successive Saturdays. Shows the average number of cars entering a shopping center parking lot. Total number T is minutes after 9. Okay. Value N is the number of cars that entered the parking lot in the 10 minutes prior to that value. Does a linear, so actually I would just have to graph it.
Oh, same thing.
Yeah.
Okay.
I would just have to graph it and then see which one looks, actually let me do something real quick. Okay. I can crank this out pretty quickly. Clear. Because actually, we should probably do more than just look at it and go, well, I think it's this one. 100, 120, all over 240. 140, 160, 180, 200, 220, 240. Okay, let me go over here. Any volunteer to read these to me so I can just do it quicker?
Yeah, I gotcha.
Okay.
70,
Okay.
135,
Okay, 178, go.
210, 260, 280, 301, 298, 284, 286, 260, 195.
Okay. So if I go zoom stat, no, I did that wrong. I got to clear out my old stuff. Zoom stat. Okay. Is that the same?
No, it's different.
It's different?
Yeah.
So yeah, that's obviously quadratic. Okay.
How'd you get there?
Sorry, give me that.
I put all the information into my stat edit.
Let's use
And then I just did,
You turn on the graph.
You could have zoomed that on.
Hit play. Turn it on.
okay.
No.
No. It's number 9. Yeah, there's no.
Okay. Yeah, I thought it would be close, and I thought we had to do some testing.
It's pretty close.
No, well, I thought I'm sorry. I thought it would be tough to decide whether it was quadratic or linear. Okay, but let me show you something. Let's say if you're like, gee, I don't know, which one could it be? Well, then here's what you do: stat calc. Let's do a quadratic, and my quadratic is 0.984.
It would be close to 1, right?
Yes. Now let's do a linear. So quadratic is 0.984. Now let's do a linear. 0.647. So obviously the quadratic is just a ton better. A ton better. Absolutely.
Wait, so how are you able to tell from the graph again?
Look at it. Because it's asking whether or not it is quadratic or linear.
Is it a line or is it a parabola?
Yes. Yeah. Yep. I was using too big of words.
Yeah, you have them without.
No, I'm not saying that. I'm just
No, you
I appreciate you putting it into student vocabulary rather than math teacher vocabulary. That's all I'm saying. Okay? But we can also back it up with the R values. Yes.
I put graph, but then it like says quit or.
Come here.
Come on, man.
So, on this particular problem or the last problem?
On both.
On both of them. Okay. Okay. Well, first of all, you've got some other garbage in here that is trying to graph. There you go. It was trying to graph the equation y equals plus. That's what it was trying to do. Okay. Okay. Anything else? Or we're going to start doing some more information.
So, page 213, number 33.
213, number 33. Find the difference quotient. For some of you guys, this could be the hardest one on there. No doubt about it. The difference quotient. Okay, I will give you the difference quotient, but I would like to think that you could know that. F of x plus h minus f of x.
Are these ones we did yesterday?
Yeah. Do you want me to keep going, or is that just enough clarity? Are you sure? Okay. Okay, so my function is f of x is equal to 2x squared plus 4x minus 3. Okay? So what's the first thing I do then?
Plug in x plus h.
Plug in x plus h. Minus the whole thing all over h.
Where'd you get the f of x from?
That's from the book. That's from the problem. So this is the problem they gave us. They want us to find the difference quotient.
That's. I looked at the wrong one.
Number 33, page 213, number 33.
I was looking at 39. Then the last one's like minus the f of x.
Yeah, because this one is the function with x plus h plugged in minus the function.
Oh,
So now here we go. We got to crank these things out, man. X plus h, x plus h. So now I'm going to do that real quick here. 2 times x squared plus 2xh plus h squared. Like know how many times I've done that in my life. Plus 4x plus 4h minus 3 minus 2x squared minus 4x plus 3 all over h. I should have taken pictures of the ones that calculus kids did on the board. Yeah. Yeah. But at times they've done a really, really good job. 2x squared plus 4xh plus 2h squared
She probably was having this until we were together. Cancel stuff out.
Start canceling stuff out. 2x squared. What else cancels?
Threes.
3's. Gandhi.
4x.
4x. Gandhi. Bottom line, anything without an h should disappear. So I'm going to rewrite what's left, and I'm going to take out an h because I want to cancel. So I'm going to take out an h, 4x plus 2h plus 4 all over h.
All right.
I wish we had a calculus kid I could pull out of the hall real quick,
Why?
just because they can do this in their head.
No.
Oh, wow.
Are you saying we can't?
That's kind of insulting.
There's no way.
Yeah,
Really?
yeah.
You don't think some of us can't do that?
Miles, get up there. Do it.
Did you?
I could do that, man.
I think what was in your? Did you show me the shortcut?
Yeah, I showed them the shortcut.
What was in your?
I
class
said
that
there's got to
day?
be something.
Yeah, there's a shortcut.
Class that day.
Yep. So anyway, but this is the tough definition of a derivative, which is a calculus term, and we do enough of these that there's a shortcut that is oh so beautiful. It's just a thing of beauty. It's just like you look at it and you go, oh, thank God.
You want to tell us that?
Not yet.
After tomorrow? See, we could open a calc for like.
Really? Wait, you don't want us to know because it'd be too easy?
Somewhat.
Really?
You would get everything but the H. The H is non-important, and you'll understand that later on. But anyway, okay. What else?
Can you do 11 on page 224?
224. 224, number 11. Okay, so number 11 is actually the same type of deal we just were doing with the tables, but this is just giving you the points instead. So this one, the only difference here is we have no meaning whatsoever. It's just that here's my points. We could put all my x's in for L1, all my y's in for L2, and then do a linear regression. If you want me to do that, I can, but you want me to do it real quick? Okay. I'm going to smoke through this like a teenage delinquent through a pack of unfiltered Camels here. Okay. Stat. Edit. Okay, so you better I better get this brightened up here. Okay, be on your horse, ready to go, because I'm going to fly through this. Clear. So if you got any questions, ask them as they go. 1.3, 2.6, 5.4, 6.2, 7.5. Here we go. Negative 4.1. Negative 0.09. Do you see where these are coming from? Okay. 1.2. 7.6. 10.5. Okay? So what do we want to do? We want to find the linear regression equation for the given set. So what I'll do is we'll go ahead and I'm just going to plot it just to make sure that it looks linear. Yeah, maybe not the most linear, but it looks somewhat linear. Okay, so now let's go back to my home screen where I'm doing all my calculations at, all my 4 plus 2s and times 6s and 2 times negative 3, which I just saw an Algebra 2 student do the other day on their calculator. Yeah, 2 times negative 3. I was like, interesting. Okay, so then let's do a linear regression. So stat, calc, I know I could have just hit enter, but I'm trying to show what I'm doing. So now, what would you write down on your test? you would write down y equals 2.223x minus 7.364.
So you want to do it with your decimal place?
Yeah, whatever. A couple decimal places is fine. Here's your form right here. Y equals ax plus b. My a is my slope, so y equals 2.223x minus 7.364.
That's all we do for that part.
That's all it asks you to do. Find the linear regression equation. And this one, I would have a moderate level of confidence in this with a 0.89 r squared. Yeah, I wouldn't bet my life on it, but I'd say, oh, it might give us a decent idea. I will ask you this here real quick. Let's see, if I go back to my graph, whoa, okay. If I used a table and would, well, let's see, how do I want to do this? There's my data. If I used that equation that we just came up with to come up with a prediction for the value of x equals 4, would that be interpolation or extrapolation?
I don't know what that means.
We haven't talked about that in here before?
Just a little. We talked about it a little bit.
Interpolation is inside my data set.
Oh, no, that's okay.
So this would be interpolation. Extrapolate is to think about future things that maybe haven't happened yet or outside of our data set. So if I want to find out what it is when it's 10, that would be extrapolation. Outside, exit. Okay? Inside, so if I wanted a prediction at like I said, 3 or 4, that would be interpolation. To interpolate. Just makes you sound smart. Oh, that might be the pattern, but we could extrapolate this out for a couple of years, and it looks like it might be $3 by then. So.
You think that works? Does that work in real life?
What?
Make yourself sound smarter?
I think that the way a person communicates makes or breaks a lot of things. Like if I'm reading something and they use the improper use of there, that tells me a lot about their level of intelligence. It does. Okay?
Do you think it shows that someone's more intelligent if they can use higher words?
I think there might be something to that, but there are some situations I'd be more interested in that. Like say if somebody's fixing my car and they're using the improper words of there, well, I'm not gonna say, okay, now wait a minute. But if I'm having somebody do looking to somebody for some professional advice, well, then I expect, good communication. So.
I always wondered because, why say a more difficult word if you can just say the same thing? And,
Yeah,
you know what I mean?
I understand. Sometimes people use words just to kind of try and impress or make things sound better than they are, but so. But I think overall, a larger vocabulary does relate to a higher level of intelligence. There's no doubt about it. And they say one of the best things you can do to establish a higher level of intelligence is read. So, and I don't read a lot, obviously.
I couldn't tell.
Yeah, I know. But I should. I don't know. I'll read articles online, but I'm not going to dive into a book. That's just me. I wish I maybe would have that habit.
What? Sorry.
I'd rather do logic puzzles, stuff like that.
Sidetrack. Why is that? Is reading books better for your understanding of?
That's a great question, but research shows it time and time and time again.
Because if you think about it, reading books are just stories. Well, it's like reading books on how to.
Yeah, you need to do some nonfiction stuff too.
Yeah.
But but maybe that is the way that most people gained information prior. Now, maybe they're gaining information a different way. But I doubt that you could say that the more intelligent person spends more time on their phone because even though that's how you get information. So I don't know. It'd be interesting over time. I think they're going to find out the impacts of a phone over people's intelligence and retention of information is a crushing blow to intelligence. It's unbelievable, the difference in trying to teach my students something now versus trying to teach my students 10 years ago. It's nuts.
In a good way or bad way?
Bad way.
Is it really that, like, way
Oh
better?
my! No, back then kids would just remember information so much better. I've got this whole theory about it, and I think that research is going to prove it to be true. If I wasn't recording, I'd go ahead and share that with you because it makes total sense.
So we're dumber than kids in the past.
You don't retain information as well.
It's just weird that, like, back then I feel like the classes weren't, like, you didn't have super easy, like, hard classes available, I feel like.
Back then, you didn't have.
Or, like, most high schoolers or whatever. Like, you had a lot of high schoolers taking, like, calculus 20 or 30 years ago.
Yeah.
Really?
Mm-hmm. Yeah. And I would say, honestly, that geometry 20 or 30 years ago was exponentially more difficult than geometry is now.
Really?
Hmm? That's just, I wouldn't say exponentially, but I'd say significantly. So.
Do you think that, like, big tests, like the SAT and SAT, are, like, easier too?
No.
No?
Not really.
So if you got a 35 now and a 35.
That's a good question. That's a very good question. Whether or not it's relatable, like say is a 30 back then equivalent to a 30 now, that's a good question. The only thing that's probably different now that I could see real obviously is back then we didn't ever prepare for ACTs. We just took it. And that.
Just like being in school.
So, yep. Yeah. Last problem.
For problems like G of H is, let's say it's like 3, would you put the 3 into G or H?
Okay. So G of H of 3. Okay. So where are we at here? You would plug in 3 into H first. And realize that is the same thing as G composed with H of 3. Those two are the same thing. They're just written differently. But I also want you to be able to find G of H of X if, like, say, G of X is equal to X squared plus 1, H of X is equal to 2X plus 3. I want you to you need to be able to write a formula for G of H of X. Yeah.
What if it's like G minus H of 3, or times 3?
You just take the function G minus H.
Plug in 3 for all the x's.
Well, you could do a couple different things. But anyway, to finish this thought, and then I'll finish yours, I would take this, plug it in for X, and simplify. Because H of X has to be done first, and that gets put into G. So if I was doing, like, say, G minus H of 3, you could do this one of two ways. You could find G of 3 and then minus H of 3. You could do that. Totally fine. You just find the value of one, value of the other, and then subtract them. Or you could come up with a formula for G minus H of X, and then when you just have that simplified, you could plug in 3.
So I can just simplify. Yeah, that's fine.
Okay, you can do it either way. More than one way to skin a cat. Meow.
Probably kidding. Any more practice problems?
Do I have any more?
Yeah.
There's 3 sections full of them, and odds.
Interesting. And, like, for the remembering thing, back then, I feel like it makes sense because, like, say you have TikTok, right?
Yeah.
Say, like,
I'll shut this off and I'll talk about it.
the average, like, person
Mm-hmm.
would probably watch, I don't know, say, like, not average, but whatever, say you watch 50 TikToks a day,
Yeah.
or just, like, scroll through or whatever, that's 50 more than back then.